I'm recording. Okay. So this is lab 11. Lab 12, we will start React. So we will start using a sort of a library framework. I never understand the difference. That will start next week. And then we will do React for a while. So test 2 will be SVG, which was last week's topic, or maybe the week even before. Today's topic, which is about parents and children and what I call neighbors, and then and then React. So test 2 will be those 3 topics. So the one thing that we had in lab 8 was XML, and I boot XML to like test 3. So we will do the SVG. That will be like the easy topic for the test and for test 2. And today's topic, which I don't think is hard, but a lot of people find hard. And then React. And React is a thing that I do think is hard, and some people agree with me. So so we just finished test 1. Those will be the topics for test 2, which won't be for a while because we haven't even started React. Okay. So here we go. I just have 2 examples and then the lab. All right, so open up that, download that. Downloads good, okay. It just showed up, okay. All right, so I give up. Folder, open the folder. It is in downloads. And it was called neighbor table. Okay, and let me, live server is an overkill for this guy. And so this guy works with a mouse over event, and when the mouse is over a cell, it colors that cell and all the surrounding cells. And so that's what this exercise is about, is how to work. So HTML has a tree-like structure. And so we have this concept of that you might have a parent and you might have children, and that is the way the things in HTML are arranged with parent and child. We worked with the slightest little bit with sort of radio buttons and checkboxes, that there's one way to work with an input and its label if its label is a sibling. So there are 2 ways to make a connection between a label and an input. And one way is to have the label be the parent of the input, and the other one is to have them be siblings. And we had some code in some of our early programs where we referred to the label as the next sibling. And then when I had some students who had the label as a parent, but had code still referring to it as a sibling. So if that drove you crazy, this is going to drive you even more crazy, because we're really delving into parents and children in this one exercise, this one day. Okay, so it's a different event than our usual event, and then it's a mouse over event, but we're also going to work with parents and children to see how do I find the row above or the row after, and so on. Okay. So I have a page. I have a little bit. Here's my teeniest bit of styling. TD is the cell of the table, the table data item, and we gave it a thick border. So that's why you can see those cells in black outline. So that's all the style we have. And then I just have hard-coded table. So I have a header, just for reference to test 2. If I ask you to make a header, and I will with your name in it, and I'll give you a point for that. If you put your header in the head, I will take off 1/10 of a point, because the header is a visual thing, and the visual things other than the title, which is shown as the tab, everything else that's not on the tab, everything visible that's not the tab, should be in the body. So the header belongs in the body. Okay. And I've said a number of times, I think, that there's a head and there's a body and there's no neck. And if you put an HTML comment in there, I'll take it, because it's still, you're still within HTML. But anything else that you put between the head and the body, I'll probably take off 1/10 of a point or something like that. HTML is forgiving, but as I say, I am not. Okay. So I make a table. Table has a table row. The table row has table data items, TDs. One can also have in a table additional tags. This is a sort of a minimal table, but there's like a tag like T body and T head, like there is for a page, a body and a head. You can have a head and a body of a table, and you can get away without those tags. And so I am getting away without those tags. But if you were to have a table that allowed for sorting, if you had a bunch of information in a table and it was like a table which you could click at the top and sort everything, that's a pretty familiar pattern in web pages, is to have such a thing. Then you want the T body and the T head. I'm not doing anything as fancy as that, so I don't have a T body and a T head. So this is the structure of my table. There's a table tag. There are a set of row tags. Within the rows, there are TDs. And then I have, this is a non-breaking space, so that there's something in the cell. Some browsers won't render a cell if there's nothing in it. So I put at least a space in it so that there's something in the cell to be rendered. Okay, so let's talk, before we get down into code, just about parent-child relationship of HTML. And so if you have an open and a closed tag, then you have things that are inside and they are the children or descendants. So I have a table, and then that table is the parent of the row. So here's a row. So the parent, compared to the row, the table is the parent and the row is the child. And then I have multiple rows. Here's my first row, then there's my second row. The rows are siblings of each other. And then the row itself, in turn, has a child of the TD. And then the TD has an inner HTML. So that can be considered the child. I'm not going to worry about that as a child, but it could. So what's inside the table is its children. What's inside the row is its children. What's inside the cell is its children. And so we have this concept, if you are at the same level, so if you share the same parent, if you're at the same level, then you are siblings. Okay, and so there's the table, and that's all there is on the page, and then we start the script. Okay, so I am grabbing This is get elements by tag name. So we've gotten elements by name, like for sets of radio buttons. That was when we gave them a name, an attribute name. This is getting elements by tag name. So all the elements that share the same, have the same tag, and it's the TD tag. So that's all the cells of my table. So I'm gathering all the cells of my table and calling them cells. I'm looping over the cells. I'm giving them a mouse, so I'm looping over all the cells. I'm giving them a mouse enter event. So that is when the mouse comes into the cell, when it enters the cell. There's a very similar event of mouse over. So there's enter, over, and leave. Sort of enter, as far as we're concerned, enter and over are sort of the same, but there can be a distinction. Okay. So I have a cell, I'm adding a mouse enter event. If I need a function to handle the event, I'm working with an anonymous function. So then I just immediately go defining the function. I want to have reference to the cell. And so when you're over an item, when you're in a function and there was an item, there was an element whose event brought you to this function, then the word this refers to the thing that brought you here. So I have a number of cells. This is the cell that is currently being invoked by the mouse enter event, and I'm going to refer to it as me. And then now I'm going to start the parent-child relationship in code. So I talked about it in HTML, now I'm going to talk about it in JavaScript. So I'm going to get the parent of that cell. So I'm in a cell, I'm getting the parent of the cell. That is, I called it my parent. It would have made sense to call it my row, because in this case, the row of a TD, the parent of a TD is a row. So I could have called this my row. I could have called this my cell. You can change my language, what makes sense to you. But this is me getting the parent, and the parent is a is a row. Okay. Is that right? Now this is me is again the cell, and I'm changing the style background color to red. So we see that the cell that I'm over is red. I have a little gap between the cells I can get between them, but if I'm entering a cell, that cell turns red. That's this line of code, 91. I have a parent, which is the row. I have me, which is the cell I'm in. And this is me finding my position within my family. So my parent, I'm not an only child. My parent has other children. And so this is an array. My parents' children is an array, all of the TDs that are the same level as me. Then I am using the index of property of an array to find me within my row. And so the first one, you know about arrays in computer science. The first one will have an index of 0, then 1, then 2, then 3, then 4, then 5. So the index is my position starting at 0 on the left within my row. So am I the first child, the second child, the third child? What child of my parent am I? Okay. If the index is greater than 0, if I'm not the oldest child, then I'm going to go to the child to the left of me by subtracting 1 from the index and making it blue. So you can see that in the same row, I'm the red one. In the same row as me, in my family, the one to the left of me is blue. That's what we did here. But I only did it if the index was greater than 0, so that if it was possible, if I'm not the first child, then there's a child before me. Make the child before me blue. That would be my older brother. Then I say if the index is less than, we know then if there are, how many things did I have? 1, 2, 3, 4, 5, 6. So if there's 6 kids in the family and they're labeled 0, 1, 2, 3, 4, so then the highest one is the length minus 1. So that is the highest index. My parent.children.length minus 1 is, for this case, all that comes out to be 5. But that's the highest index. And if my index, if the cell's index is less than the highest index, that means that there will be a younger sibling. And we're turning that green. So this is my, the blue was my older brother and the green was my younger brother. So I'm red, my older brother's blue, my younger brother's green. Okay, so that's sort of my generation, my immediate family. I go to my parents and then I ask my parents about their other children. Now, we obviously have more than that because I have stuff above and stuff below. So I'm going to go to my parents' parent and then ask them about their children. So now I'm going to go up to my grandparents and ask about their family. So now I'm finding who is my parent's parent, which is my parent's parent node. So now I'm asking who's my grandparent. The grandparent is table. I'm in a cell, TD. The TD's parent is a TR, a row, and the T row's parent is the table itself. So this is the table. And then I'm asking the table about its children. And I am finding my parent's index within the set of children. So you can say, what row am I in? Or you can say, who are my, I don't know, aunts and uncles or something. Okay, so this is my parents' position, within that parent's family. So, what position is my father in his family? Was he the first child or the last child or somewhere in between? And then we start asking the question again. If the parent wasn't the first child, so if there's a child before your parent in your parent's family, then let's go up one generation, let's go up one row and go to the parent index minus 1. That's my father's older brother. So my parents' children's parent index minus 1. That is my father's older brother. And let's go to his children and go to the same index is me. So if I'm the third child in my row, I want to know who my father's older brother's third child is. And we're making that yellow. So what's in the row above is yellow. That's here. I'm going to stay in that row. So I want the parent index to be greater than 0 to know such a row exists. And if I wasn't the first child, then let's find out who's up and to the left. So who's in the row above, parent index -1, and to the left, index -1. And we were turning them magenta. And that's that pinky purple color in the upper left. If I'm not at the edge on the other side, if I'm not on the right, then I'm going up a row. I'm going to my father's older brother and going one child later than me, if that exists. And I turned that. I was hungry, so I went for chocolate. So that's that sort of browny orange color on the upper right. And then I'm going to go below a row. First, I ask, can I go below a row? So this is the question. Can I go down a row? Is the parent index at the limit of parent indices? Yes or no? If it's not, then I go one row lower, which I go by saying parent index +1. Directly below me, so I give it the same index, I'm making that cyan, which is sort of an aquamarine color. That's that light blue right below me. And then the same question again. If I'm not the first index, then there's somebody to the left of me, and there's also somebody to the left of me in the row below. Let's make that pink. So that is the lower left. And then finally, if I'm not the last one in the row, then I'm going to the row below me. And if I'm not the last one in the row and there's a row below me, then let's go to the right of me and down a row, and we turn that lime. So that's that bright green. So this is the game, how to find out my position in the family, and then how to sort of move around within the tree structure. And the hard part is the ifs, to check to make sure that there is a child before you go examining the child. So this is very much an inspect thing. There's that like fave icon thing that always pops up. But when you're doing this exercise, you should not be getting errors. It will sometimes it will do what you want it to do for the most part, but you'll be generating errors. And that's one thing I'll be checking for. On the lab, if you've struggled on the lab and you didn't get all the error free, then I'll probably, but if it does mostly what it's supposed to do, I'll say, oh, here, have 100. But on the test, if it's not error free, you're losing points. Okay. And then here's the corresponding mouse out. So it's just all the same. Mouse out is when I leave. If I don't have a mouse out, then it changes color and it stays that color, unless I overwrite it with some new color. But if I want it to go back to white when I leave, then I need a mouse out. I don't want that. What did I just do? And so I'm looping again over all the cells, this time working with a mouse out event and my anonymous function. And it's almost all the same, the whole same if structure, except I'm setting the back color equal to quote, quote, which is getting me back to my default color, which was white. So that is it's all the same ifs, and all it is just quote, quote, instead of a particular red, blue, what have you. Questions? Okay. None, all right. And we go back. And then we go to Minesweeper, where I'm going to use some of the stuff to play a Minesweeper game. So here's Minesweeper. And I'm opening it with a live server. And I cheat in Minesweeper because I'm really bad at it. So the red is the bombs, which I should in a real game hide and that somebody's trying to discover. But if I turn over a cell, it will tell me that there were 0 bombs next to it. So if I'm here, it's going to tell me that there are 2 bombs next to it. There's the one right above it and the one over here. So this will say that there were 2 bombs. This one will tell me that there was 1 bomb. If I click right here, I'm going to get that there's 1, 2, 3, 4 bombs near me. If I turn over a place where there are 0 bombs, it knows that all the cells around it can be turned over, and so it does it automatically. So if I click here, every time it sees a 0, it clicks everything around it, and then if those are 0s, it clicks everything around it, and so what do you call that? If I have a function that is handling a click, and then it effectively does a click for me, calls itself. A function that calls itself. All right, you all fail. Function that calls itself is recursive, thanks. Okay, so let's have a look at Minesweeper. All right, so I have a cell. I gave it a border so I could see my cells. I have a class called hasBomb, which I make red, so then I can see the bombs, because I'm cheating because I'm not good at this game. And then I have a been there class because I need to know where I've been so that I don't keep clicking on the same things over and over again. And if I'm going to do recursion, I need to have a base case so that my recursion doesn't go on infinitely. So you saw that the cells that I clicked in, here's the bomb class, that's the red. Once all these things get turned over, that gray, that is the sort of been there, done that class. So that's that gray. Okay, so that's just the style, but we can see the role the style is playing in the visual of the game. The red is my cheat. If I didn't click on a red, but if I click on a red, it just turns over everything and I lose. Okay. Here's basically the same thing I made before, a table, rows, and cells. It's pretty much the same HTML as before. Here are all my cells. Here's me saying that there are n bombs. There are, well, in this case, 10 bombs. And I have an array of bombs. And I'm making 10 of them 1s and the rest of them 0s. So that is specifying the number of bombs I have. So I start off with the bombs all in the beginning and none at the end, but then I'm going to shuffle up the bombs. So this is a code for shuffling that array. And there are many languages have a built-in shuffle. I just wrote my own, used to writing my own. So this is me moving around the bomb so that the game is fun, or at least challenging, if not fun. Okay, so now I'm looping over my cells and I'm saying if the bomb for that position is a 1, then I'm giving it the class. This is me adding the class has bomb. That's what made it red. Anything that has the class has bomb turns red. And this is me, all my cells had no class. There were no classes in these cells, but I added the class. Where did I add the class? Here I added the class of has bomb when the corresponding bombs array was a 1. So it added the has bomb, and then by the styling, it made it red. Okay. Because I'm cheating. Okay. Now I switched over the event to a click event. I'm not, so what we worked with previously was the mouse over, mouse enter event. Now I switched to the click event. But a lot of the game is the same. I find out who I am. I find out who my parents are. I find out my position in within my family. I find my parents' parents, and I find my parents' position within their family. So that's all just the who am I, what position am I in my family, who's my parent, what position does my parent have in his family. Okay. If I am working with a cell that is in the bin there class, I get out. I'm going to do recursion. I'm going to do that little bit of recursion, and I need a base case. And this says if I'm in a cell, if I've clicked in a cell, or if recursively I'm clicking in a cell that's already been clicked, just be done, get out. And so then I'm out of there. If the cell that I clicked on, or that the program is pretending to click on recursively, if we've already been there, leave. And the next thing we do is, if it's a new cell, then give it the bin there class, so that it turns gray to tell the user that, okay, that's a cell that the user's now clicked, but also provides the base case for the recursion and gets us out of there, so we're not in an infinite loop when we attempt the recursion. Okay. If the cell I clicked on has a bomb, I make its inner HTML a B, and I run a function called end the game, which just turns over everything. And so end game, loops through everything, effectively clicks everything, and just dispatches all the click. Just clicks everything, turns over everything, you're done. Yeah, I'm clicking it for you because you're done. That's if there was a bomb. Okay, so we dealt with the, was it a bomb in the game? Was it already clicked? Get out of there. Mark it so that it knows if it's been there for a later case. Now I'm playing the rest of the game is to count how many bombs. So if I'm here, I'm next to 2 bombs. If I'm here, I'm next to 1 bomb. If I'm here, I'm next to 3 bombs. 1, 2, 3. If I'm here, I'm next to 3 bombs. 1, 2, and 3. If I'm here, I'm next to 2 bombs. So I want the computer, of course, to do that counting. So it's all the same logic of go around my neighbors if they exist, and if they're bombs, then count up, do a count. So I have a variable bomb count. I start off at 0, and I go to the left. If my index is greater than 0, so if I have somebody to the left, and if that person to the left has a bomb, add to my bomb count. Can I go to the right? If there is somebody to the right, and that person to the right has a bomb, add to my count. So that's my neighbors on either side of me on the same row. This is the row above. So it's the same logic as the program we just played. Is somebody above me? Is there somebody above me? Is there somebody above me to the right? Is there somebody above me to the left? And then we're just adding in do they have a bomb? So if there's a row above me, then and it has a bomb, increment the bomb counter. If there's a row above me and there's a cell to the left of me, and that row that's above me and to the left of me has a bomb, then add the bomb count. If there's a row above me and there's a cell to the right of me and that cell has a bomb, then add the bomb count. Same thing for the row below. If there's a row below me and the cell below me has a bomb, then add the bomb count. If there's a row below me and there's a cell to the left and it has a bomb, then add the bomb count. And if there's a row below me and there's a cell to the right of me, and that cell that's in the row below me and to the right of me has a bomb, then add the bomb count. And then I make my inner HTML bomb count. So we saw that. That's when I click on a cell, this is going to be display the bomb count 1. Here's the recursion. You all love recursion. If the bomb count was 0, then I can go all around it if the neighbors exist and click and make click events. I can call the click event. I'm in the click event. I can call the click event. That's the recursion. And so if there's if I'm not at the edge, if I'm not the first child, then and I don't have any bombs, then that means that I can click on and turn over the cell to the left of me. If I'm not at the edge, I can click over the cell to the right of me. And again, all the logic again. If there's a row above me and right above me and above to the left and above to the right, dispatch the click event. So if I was 0, if I didn't have any bombs, I can go all around me and click those things. So I'm using this logic over and over again. Who are my neighbors? Can I go around? I went around to do the bomb count. And if the bomb count was 0, then I can go all around and click. And then those things can go around themselves and click if their bomb count was 0. And that's why you get something like this. If I'm down here, you get a big area. So if I click on something that's far from everything else, it clicks its neighbors and they turned out to be 0 and they click their neighbors and so on. And then we are done. So there's just lots of ifs. It's a very iffy thing. Okay, so that was fun. At least I had fun. What do you have to do? Something different. You don't have to do any recursion, but you do have to do a lot of ifs. So you're doing this program I call night moves. And I just gave you again the neighbor table and the Minesweeper in there. And I gave you a picture of a night. And so here's what you're doing. Let's view it. Page width, okay. So the board gets sort of generated, the 8x8 to make a chessboard gets generated. You put, and I think I have code to place the knight, the white knight randomly. And then we'll go back to a mouse over event. So if I put the mouse, only if I put the mouse over the knight, so there's an if there, only if the mouse is over the knight, then I go the way that a knight moves in chess, and that's over 2 and change by 2 in one direction and 1 in the other. So it's not my immediate neighbors, but it's this pattern of neighbors that are a little bit farther out. So from the horse, there were 2 to the left and 1 up, or 2 to the left and 1 down, or 2 up and 1 over, or over in either direction, or 2 down and over in either direction, or 2 to the left and either up or down. But if you get into, if your horse, which is positioned randomly, ends up to be at an edge, then you're not going to, you can't display some of these. And so that's where the ifs come. So again, once you get it going, then what you want to do is open it up like I did here with the console open, and see if you're generating random errors. Okay. So that is what you have to do. Any questions? All right, I'll stop recording.